Hello to everyone. My name is Irina Deeva, and today I would like to present you our research, which is called a multimodal approach to synthetic personal data generation with mixed modeling, Bayesian networks, generative adversarial networks, and classification models. So what is the main subject of our research? What is the main purpose? Actually, nowadays, dataset availability is a critical factor or critical reason of development of machine learning project. Because if we're speaking about personal data, especially about personal data, privacy restriction can be a problem to develop such data analysis projects. Because sometimes some companies, for example, would like to have projects with research groups, but they can't share their data because of privacy restrictions. And of course, for example, when I'm speaking about the medical data, we understand that this kind of data also should be anonymized. Here we are speaking about the anonymization of personal data. Of course, you can use, for example, open source data, but usually such kind of data is not diversified and is not suitable for research. That's why here we can talk about synthetic data, because synthetic data is not real data, is not personal data. That's why such privacy restrictions can't be applied for such kind of data. But here we will talk about especially synthetic personal data and especially about synthetic profiles. Here you can see the synthetic profile contains different types of data. For example, it's tabular data, like some socio-demographic data like age, gender, education status, interests, and so on. But also we have some graphical information like the portrait, the synthetic portrait like avatar, and synthetic content images. And all these synthetic objects we can describe as a multimodal object. Let's formalize our problem. First of all, when we're speaking about the personal data in tabular form, we can consider such kind of data as multidimensional random variables, which combine categorical, discrete, and continuous values. Also, we should understand that the synthetic portrait must be consistent with tabular data. What does it mean? For example, if your synthetic data, synthetic profile contains information about age, for example, 18 years old, it means that the synthetic portrait also should image a person who is 18 years old. That's why here should be the link between synthetic tabular data and synthetic portrait. Then when we're speaking about the synthetic content images, which we can find in synthetic profile, we understand that usually people post some images according to their interests. That's why in synthetic profile, this link also should be. And that's why some synthetic profile images should be consistent with personal interests. And the last but not the least point, that for training, usually for training such multimodal models, we need interrelated data sets. What does it mean? Usually we should collect the tabular data, the images for one person. It means that these datasets should be connected, but usually it's very difficult to collect such interrelated datasets. For example, here you can see some solutions in this sphere. For example, for generation multidimensional data, we decided to use Bayesian networks because it has a high level of interpretability, and also such kind of models can combine discrete and continuous data. Then for generation images, we decided to use generative adversarial networks because there are a lot of architectures that can be used for conditional images generation. But we should remember that there are also some multimodal autoencoders models, for example, that also can be used for such kind of generation. But the main disadvantage of this model that they need interrelated datasets for training. After this analysis, we construct such kind of pipeline for generation synthetic profiles, which combine different kind of models. And main advantage of this pipeline, that's all models, for example, Bayesian network, generative adversarial networks, can be trained separately on its own datasets. And we construct the link between models in such way that the output of one model can be the input of other model. For example, here you can see that the output of Bayesian networks is tabular data, but this tabular data is input for generative adversarial network, and after that we get the image of person, synthetic image of person, which is correlates with synthetic tabular data. And also to content images. For example, the synthetic interests data can be the input for content images generation model, and these content images also correlate with synthetic interests. After that, we combine all synthetic parts and get the whole synthetic profile. But let's speak about each model more precisely. The first model is Bayesian network. Bayesian network is a directed cyclic graph. Actually, the main idea of this model that we can construct the multidimensional distributions according to such model. To do some structural learning, we used greedy hill climbing algorithm with K2 score function. The main idea of this algorithm is quite simple: to find such a structure which has the highest level of score function. Then to do parameters learning, we should understand that here we have different kind of distributions: discrete distributions, continuous distributions, and conditional continuous distributions. And for example, when we use conditional Gaussian distribution, we can combine discrete nodes and continuous nodes. Then for our generative adversarial network, actually here we used such architecture where we generate some images from noise and then use auxiliary classifier with such parameter as age, gender, and ethnicity to understand has we generated the synthetic portrait with certain parameters of age, gender, and ethnicity. Then here we see the model for content images generation. Actually, this content images generation model is not generative model, but also the discriminative model, because to generate different images is a very difficult task. But for example, we can classify images according to the interests. Interests we describe as the text, and actually in our zero-shot classification model just match this text data which describes interests with some images. And when we use such model, we can just match our text of interest with suitable images. And these images can be used for synthetic profiles as synthetic content images. So here you can see some information about our data. We use data from Vkontakte social network. Here you can see that we have not only discrete data, but also continuous data. And here you can see the structure of our Bayesian network. And what is the main reason why we used name or ethnicity node as disconnected node? Actually, we use it to make our data more tolerant and more diversified, because sometimes all datasets has bias which is connected with ethnicity, and to delete this bias, we decided to disconnect this node of ethnicity from other nodes to make our synthetic data more diversified. Here you can see the results of synthetic data generation. Actually, the quality of synthetic data is quite high, especially when we're speaking about discrete data. But if we look at continuous data, we see that we have some difference. It can be caused by using only Gaussian distribution for approximation of real distributions. But in the future, we are planning to use mixtures of Gaussian distributions to approximate such difficult kinds of distribution. Here we decided to compare the correlation matrices which were constructed on real data on the left and on synthetic data on the right. And you see that these correlation matrices are quite similar. So here you can see the results of accuracy of synthetic portraits generation according to different attributes. You see that this accuracy is quite high. It means that the result synthetic portraits actually correlate with all these attributes. Here you can see the example of synthetic profile. And also we did some kind of survey during that approximately 17% of people believed in the reality of shown synthetic profiles. Here you can see also some different kinds of synthetic profiles. You see that, for example, here we have some synthetic interests like vacation, sea, and so on. And all these we can see on content images. It means that we have correlation between interests and content images. Also, we have correlation between name or ethnicity and synthetic portrait. And of course, between age, gender, and also the synthetic portrait. After that, we decided to construct such experiment where we decided to generate not only common datasets, but also the datasets of social groups. We consider two social groups. The first was married people, and the second were women. And then we compare the original distribution of interest, a synthetic distribution of interest for two social groups. For example, here on the left, you see the results for married people, and this is the result for women. And we see that the synthetic and original data is quite similar. It means that we can use our model, our pipeline, not only for common data sets generation, but also for generation some specific social groups. So what we can say at the end, first of all, we construct multimodal approach for synthetic profile generation. Experiments have shown that the quality of synthetic profiles is quite high. And also in the future, we are planning to construct a web service for using our model to make synthetic data is available for all people. Actually, what is the main advantage of our approach is that it doesn't need using interrelated datasets for training. It means we can train each model for separate dataset. But also it has some disadvantages. For example, we have some difficulties with working with non-Gaussian distributions, but it can be solved by using mixtures of Gaussian distributions. So that's all. Thank you very much. And I'm ready to answer your questions.